Welcome to NCIX Tech Tips. Today's episode is extremely exciting. We're going to be doing an exclusive tour of Intel's SSD facility at their Folsom campus in California. We're going to be interviewing some Intel employees and checking out some really cool facilities, including their RMA, as well as their testing and validation for upcoming products. So the first thing we're going to do is a little interview with James, but we had a technical glitch and we lost the footage for his answer and my question to him while I was actually down there. So we're going to do a bit of a virtual handoff here, and I'm going to say, James, explain something to me. If this is flash and this is flash in a USB drive, aren't they pretty much the same thing? Let's see if I can throw a drive all the way to California from here.
Well, no, the NAND inside an SSD is not exactly the same as the NAND inside a USB key like this. What's interesting about the NAND that Intel uses, it's compute quality NAND, which means we do a few things differently. We bin the NAND to make sure that it's the best NAND from a quality and reliability perspective, and it meets all the requirements for an intensive compute application, like handling lots of read and write cycles and not randomly failing, although in the USB key that might just happen. The other things that are interesting about the compute quality NAND, when we put it inside an SSD, we protect it. We add features like XOR, and we add extra data integrity through ECC, things that you're not going to find inside a USB controller. So no, not all NAND is created equal.
Hey guys, welcome to the Intel Folsom campus. You can see there is a huge burly security guard here who will be giving me my guest pass, so stay tuned and we're going to do some pretty cool stuff here at the Intel office. So this is Arbin, and he's going to tell us a little something about SSD testing and validation. So I have one SSD in front of me, which may seem very interesting and, you know, very cool and all that. But in order to achieve the level of reliability that Intel does with their SSDs, they need a few more drives than this. So Arbin, I want you to tell me what 1,000 drives for 1,000 hours means in the context of Intel and what that allows you guys to achieve.
Well, we at Intel try to please the enthusiast, first of all, right? So what we try to do is to test the drive in the case where most enthusiasts using it in the worst case condition, we can predict what the failure rate's going to be. You yourself, being an enthusiast, how much data do you think you write to the drive in any given day?
Realistically, I probably write in the neighborhood of, on a slow day, maybe 5 gigs, maybe 10, 20 gigs.
Okay. A typical user, based on years of research, a typical user will write less than 20 gigabytes per day on an SSD. We at Intel test our SSD at about 1 terabyte per day. In 1,000 hours, we write roughly 36.5 terabytes to the drive. Why do we do that? We really want to focus on proving our overall AFR for our enthusiasts, our annual failure rate for people that are going to use the drive in worst case conditions, exactly. And that's really to cover our overall product reliability, product quality, and demonstrate what our AFR is going to be long term.
So basically, that allows you guys to achieve sort of come on, give us a rough number. What rank in terms of failure rate within the SSD industry?
We're number 1.
There you go. Here we are inside the belly of the beast. So this is Intel's testing and validation facility in their Folsom campus in California. So what you see in front of me here is actually their SATA 2 box that they use to validate for things like withstanding certain operating temperatures. They're also validating the overall reliability of the drives. So I'm going to show you guys a couple other cool pieces of equipment here, and then we're going to move on to Intel's philosophy when it comes to validating their products before release. Alan, tell me something. I was reading on the internet, and I found an article that was by researchers who say that SSD technology is a dead end. We're going to slam up against a wall in terms of whether it's capacity or reliability. I'd like you to contemplate this for a second.
Those same guys want the CD back, have 8 tracks in their cars, are looking to where things used to be, not to where they're going to be. We at Intel Obviously, we believe in one law, and that's Moore's law. We believe in the smaller lithographies. We believe we have cutting-edge technology to continue to move smaller and smaller, which means for any consumer, you're going to have bigger capacities, better prices as we move along. That's what technology does. SSDs provide better performance, better reliability, are definitely more rugged than any hard drive will ever be. So as we continue to move forward, we're going to have the better capacities at a way better performance than a hard drive ever will. And as we move a smaller lithography, we'll have some other things in store to continue to make NAND the future of storage.
Now, not all of these expensive test machines are even created equally, so Intel has to be constantly upgrading or replacing their existing facilities in order to meet the ever-changing needs of the technology. So the one you see here is actually for SATA 3 and SAS validation. So there's a boatload of drives plugged in here, and not only do they need separate machines for SATA 2 and SATA 3 and SAS, but any other interface technologies that we're likely to see SSDs released on, Intel has to make sure that they have the appropriate specialized equipment to make sure that they're always on top of their game when it comes to the reliability and the performance of these drives. Now, no matter what validation processes you put in place, if you ship as many SSDs as Intel, even a 0.1% RMA rate means you still get back a fair number of drives. But the most important aspect of that is what you do with the drives that you get back. So you can see in front of me here, we've got a whole pile load of SSDs, including recent stuff like the 510, older stuff like the X25. And what Intel's doing with this pile of SSDs is they are determining what caused the failure and how they can improve the processes in the future. In fact, many of these SSDs, my understanding is actually a lot of them compared to how many came from end users, are actually from their internal validation, where these never even made it out into the field. But because they're constantly working on the process, just like they do with the CPUs, they end up on this table, they sort them into exactly what went wrong, and figure out how to fix it. So here at Intel, I went on a bit of a safari, and what I found was a female IT industry employee. Allison is going to talk to us about the Intel 520 series specifically, but the overarching theme of this conversation is actually very relevant to Intel's SSD strategy as a whole. So as you guys probably know, there are so many SandForce controller-based SSDs on the market. Some of them are using Intel NAND, am I right?
Yes.
Are they using Intel NAND on the latest processes?
Yes.
Okay. So, someone came to Intel and said, okay, well, here's an OEM design, other SSD, you can see the SATA 3 connectors. Why is it that it took Intel so long to come to market with a SandForce SATA 3 SSD?
So we took the SandForce and our NAND, ran some tests on it as it is with the one that our customers have released, and saw that the quality of this drive was just about here. And Intel already had a quality bar up here, and it wasn't good enough to release a product that wasn't the same quality as what we are known for.
So what you're saying basically is that if someone else takes a product, they test it and then they give you a spec. Whereas
we take it, we'll actually run our tests. If it's not good enough, we'll make changes to the firmware, make changes to the drive to get it to the level of quality that the rest of our solid-state drive line is up here.
So in order to get it there, what did you guys have to do with the firmware?
We actually changed significant portions of the firmware to ensure that it met the customer requirements we had.
And I know this was in one of the other interviews, but why exactly would it be that the Intel one was already slightly better than the other SSD?
So the NAND that we put into our own SSDs is already slightly better to what we sell on the open market.
Now, even Intel doesn't have the luxury of just going all ivory tower and comparing only against their own products in terms of improvement and in terms of their competitiveness. So in their lab, they validate against their competition's products in order to make sure that they're going to deliver the best price to performance to value to the customer. And one of the ways that they're able to do that, there's validation and testing, but if you don't have the engineering know-how to back it up, then you don't really stand much of a chance. So this is a full wafer of flash dies, and I'm going to call them dies, although it might be the plural dice, but I'm not going to worry too much about that. These are manufactured by Intel. The process technology that allows us to keep putting more and more storage in the same amount of space is developed by Intel. And as you're going to find out very shortly, Intel has ways of making sure that they always have the highest quality NAND, because there are formulas that you can use to calculate the probability of the best quality dies on a given wafer. You can see around the very outside edges, many of those aren't even usable at all because they're not complete, but when you get right down to it with an SSD, you've got the controller, and then you've got these. These are the storage backbone of your solid-state drive, and they go inside those little black chips that you find on the PCB. Oh, I didn't see you there. Ha ha ha, so funny, right? So I hope you guys really enjoyed this inside look at Intel's SSD operation, and I really hope that you learned something today. Thank you for checking out this episode of NCIX Tech Tips, and don't forget to subscribe.